So in throughput, we generally actually outperform standard storage technologies. So we can actually speed things up.
That's an unusual result, right?
Good morning and good afternoon, whether you're watching us live or watching us on demand. Welcome to the ShardSecure webinar on Microshard technology. My name is Bob Lam. I'm the CEO and co-founder of the company. I also wanted to introduce two of my colleagues who will be taking you through this webinar today. Zach Ling, who is our Senior Security Engineer, and also Robert Stephen, who is our VP of Strategic Sales. This is going to be an educational webinar. We hope that at the end of the webinar, you will learn something about this technology, Microshard technology, and why you want it, what is it all about, and the potential use cases. I am super excited today, honestly. Can't find a better person, a better, very well-known security practitioner with us today to talk about this cloud security, how does it work, and and also the Microshard technology. And I want to welcome Ed Amoroso, who is the CEO of TechCyber, the lead analyst at TechCyber. I think many of us, or if not most of us, actually in the security industry know Ed and respect Ed. For about 20-some years in the security industry, at least, I think Ed was the Chief Security Officer of AT&T for over 20 years. And you've done a lot for the industry. Thank you for that, Ed. And I think last 4 or 5 years, your company, your research firm, TechCyber, really do continue to make a lot of contributions to the security industry, which is much bigger than when you started in the industry and when I started as well. And I know you guys are working with security customers, but also security startups, other vendors like ShardSecure. So we appreciate that. So with that, I would like to welcome Ed and also ask him to say a few words about what he is seeing out there, because I would love to hear your knowledge about the security and especially cloud security.
Well, thanks, Bob. It's great to be here. I always enjoy our interaction. You and I have known each other a while, and I always like the ideas and other types of concepts that come out whenever we get together. So it's fun to see you, and I hope people enjoy the material that we go through. So just to kind of set the stage, I think just about everyone listening is familiar with the cloud security offers that are out on the marketplace today. There's quite a few of them, and they're quite good. I remember, Bob, when I first started looking at, what appeared to be sort of nascent cloud, maybe over a decade ago, while I was working in telecom. The solutions were a little bit all over the map, but they've converged into a series of things that are usually pretty good, and almost all of them, we'll get in a minute to your solution, which I think has some very unique aspects, but the vast majority focus on that front end. So where users are coming into the cloud, we've got resources hosted in some public cloud. There's always the big three that get mentioned, right? Google, Amazon, Microsoft. And then the basic question, the functional question of how do I, establish and manage credentials, so I know the right people are coming in groups and so on. How do I monitor what's going on? And traditionally the CASB solutions have done a nice job, and they've expanded. And then finally, how do I, provide a security environment for hosted workloads that sit in cloud? And microsegmentation solutions have taken the lead there. And you wrap that all together, we call it Zero Trust. And it's really quite a nice ecosystem, something I'm very happy with. And that I think has been a big advance in our industry. So we, again, for years have talked about and worked on that concept. And then Bob, you and I started chatting. You were telling me about the work that you were doing. If Zach, if you can flip to the next chart, we started talking about something a little less familiar. The idea that, well, all right, we got all these front end kind of things, and that's good. Like I said, that's a bright spot in our industry. You should be running a CASB. You should be doing microsegmentation. You definitely should have a a nice zero trust access path based on good credential match. All good. But what about the back end, like the system administrators, the security teams that potentially have some sort of access to the tenants that are running in their public cloud infrastructure? We've all seen that those companies have gotten very big, very powerful. And I fully endorse that. Like I like the idea that there are, some number of cloud providers that we can trust. If you're a small, medium-sized business, I think in 2021, it'd be nuts to try to do a better job hosting your workload than, say, Microsoft. They're going to do a good job. But with all that power comes a new type of risk, namely its back-end access. So when they go to hit hosted workloads, it's not through that zero trust front door that we just talked about. It's not going to be through some CASB monitoring and so on and so forth. It's administrative access. So you and I were talking, and you told me a little bit about the work that you guys are doing at ShardSecure, and I had a really nice aha moment there. I thought, wow, you're right. That's been my experience in, again, in industry, doing this sort of thing my whole career, that you always knew that, in the old Unix days, we'd call it root. But if you had super user root, administrative, high privilege access to resources, then you have access, period. And there's not going to be much in an SLA with a cloud provider, whomever, that will give you much confidence that, that they're going to have, specific controls in place that would obviate that. Some may not. It's all over the map. So you and I talked about some strategies that I know you'll share with the folks here today, which I think are wonderful technical strategies. Zach, flip to the next one. I'll go through a few of the things that I think from a computing perspective, cybersecurity perspective, are really quite promising. And that as an analyst, I fully endorse that. I think we'll start with the premise that you're putting some data object into cloud or maybe multi-cloud, but generally you'd be putting a workload into cloud and you put other workloads in other clouds. We'll get to them, the nuance of multi-cloud hosting here in a minute, but just about everybody, does business with most of the big three, and there may be others. So normally you would take some data object. Let's say it's a piece of analytics, might be a big chunk of data that you're going to do some processing on. Maybe you're a bank and you want to do your analytics in Amazon or something. Very, very common. So you have data sitting there. We talked about, and I got excited about three things. First is the idea of disaggregating, meaning, you really don't need to put that data object just into one place. You really can break it up. And we know these algorithms have been around. I mean, I remember when I was a graduate student 30 years ago, studying computer science, looking at some of the early algorithms for distributed, data storage. These are not, brand new, but in the context of security, we haven't really talked about it. We rarely would say disaggregation as a security principle. We'd say separation, segregation, least privilege, trusted path. Those are things that flow off the tongue, but disaggregation doesn't, but I think it should. So that was number one. The number two was separation, the idea that hey, you don't have to put these disaggregated pieces in the same physical or even virtual location, and they don't need to be in the same cloud. You can scatter them. And I thought, I like that too. Separation is a security primitive. That is something we've seen, like a PCI and others, reference separation specifically in data centers and elsewhere, where you want to make absolutely certain that you're providing separation of objects based on some policy decision you make. So you put disaggregation and separation together, you have something powerful. But then I remember, looking at some of the work that you were doing, you guys are obfuscating, and again, encrypting, blinding, obfuscating. These are all variations on the same theme, depending on the strength or your how determined you are to make something, unreadable. But doing some sort of obfuscation on top of that, and then the result of this triad of disaggregating, separating, obfuscating, I said, wow, this is pretty good. Like I like that for multi-cloud. and have been wondering since, why isn't this something that is essentially an industry standard? And you guys do a really nice job. We spent time, went through the implementation. I think it's a very clean approach to this. So I guess the main thing is for the people listening, I'm not really here to market anything, but I am here to fully endorse that this idea, which when you put it together, we've been calling it data sharding. I think that's your name. You guys are ShardSecure, but this idea of data sharding, I really do think should become one of the basic techniques, primitives, concepts that we not only use in practice, but that we teach as we introduce people to the topic. I've been talking a little bit about this to my graduate students at NYU and at Stevens. So I think this is pretty good. You guys are onto something here. I have a feeling these concepts can be applied in a lot of different places, but the idea that you guys are doing it with data, enterprise data, to help make it more robust against different types of multi-cloud threats, I think it's a good idea. And Bob, I'm going to kind of let you get started. I know you have some technical content you want to take folks through. I'll stay, sort of off mute here and chime in when I see some pieces here. But do these three slides, they make sense? They sort of capture the conversations you've been having. I tried to draw these in a way that brought out what I thought was the most important points. But anything maybe that I've missed here, Bob, before we get started with your material?
No, Ed, I think it's very well said. Thank you for that. And you were actually the first analyst out there started talking about data sharding as a security approach around a year ago. And I really like the way you're able to crystallize, help us, we focus on the back end, data sharding, focus on the back end, rather than there are plenty of really a number of very successful front end cloud security companies out there that we talked about. Right. And I think this is very complementary, this type of technology. Yeah. And when you talk about cloud security, I have to mention the shared responsibility model, right, by the major cloud providers. I mean, you and I talked about it a number of times, and the major ones like the AWS, Azure, GCP, they actually have done a very good job. They've come a long way, right, last 3 to 5 years in really improving the security of the cloud, but the security in the cloud, which includes data security, is still, the customers still have to worry about it.
Yeah.
And there are different ways to enhance the security in the cloud. And we're really trying to. When you mentioned universities, as you know, we're doing some work with students at Stevens, and we really want to help educate the industry and about microsharding or microshard technology as a way to enhance cloud security in the cloud. So since I really want to have this focus on the technology and the use cases and why you want to consider this, I want to turn this to Zach Link and Robert, Stephen, and Zach again is our senior sales engineer. So I let them take it from here, and then after the presentation, then Ed and I can come back for Q&A if there. I assume there'll be some questions out there. Gentlemen.
Thanks, Bob. Good day, everyone. I wanted to just kind of jump into this slide here. I looked through a number of recent reports, right? The 2020 data, which is collectively 17, 18, 19, and to Ed's point, with all the collective knowledge and technologies that we have today, why are we seeing an increase in the size and frequency of data breaches in the cloud? And before we discuss Microshard technology and how it can help defeat the cloud data breach, the topic of this webinar, it's important we address kind of the most prevalent root causes and some of the related challenges we face in securing data in the cloud. And much of what all of us have been reading about lately has been related to the major supply chain attack. I don't want to mention the companies in particular, and generally other vulnerabilities in third-party software that enable attackers to potentially view or exfiltrate sensitive data. However, if you look at the data in the reports from 2020, 40% or more of these data breaches are caused by things like cloud misconfigurations and compromised access credentials, which could include things like username and passwords, access tokens, certificates, and API secrets, more than just that platform access, right? Couple that with reports from a number of industry-leading analysts that nearly half of all sensitive data in the cloud is not encrypted, and the time it takes to identify and contain a data breach being what appears to be a good part of a year, we have major hurdles to overcome. And Microshard technology could be the answer. With that, I'll pass it to Zach to kind of dive deeper into some of those challenges.
Yeah, so when I looked at this data, I was really surprised by cloud misconfiguration being one of the top initial attack vectors. And so I thought, apparently we're doing very poor as a security profession if we're giving the attackers access that that easily. So I researched a little bit, and I wanted to pull out some key findings from the Oracle KPMG cloud report that sort of highlight why these things are happening. So the first finding they had was misconfigured cloud services are a top cloud security priority. And we haven't really shifted very well from the security paradigms that we use for data center to now the public cloud. And if you think about it, there's fundamental differences between data center security and cloud security. So data centers were really built, with a philosophy of castle and moat. So they had, a secure perimeter. They had limited entry points with, a whole stack of security tools there. Servers that required internet access were segmented in their own DMZs. But public cloud was really developed with a much more open mindset. I like to think of it as more of a bazaar where basically everyone can come in and set up their booth however they want it and sell their goods. And so you really lose some of the security safety net that data centers had. The second point is basics of cloud security are still not understood. And this gets back to what Bob was talking about the shared responsibility model. And that really says that cloud providers are responsible for security up to a certain point, and then the customers take over security from there. I mean, back in the data center days, your customer's responsible for all security, so it's really easy. But with the shared responsibility model, there's a line between that, and that line gets fuzzy. So depending on what type of services you're using in the cloud, the customer is responsible for different levels of security. And just within the same cloud, different services have different responsibilities. So let's take, for example, you have an application that's using SQL as a service. And an architect, for one reason or another, they switch that to SQL running on a VM. Seems like a pretty minor architectural change, but you just went from platform as a service to infrastructure as a service, and your security responsibilities just grew. So if your security team is not embedded in the development process, early on and just ingrained in that process, it creates security gaps. And that's one of the reasons we're seeing a lot of breaches due to just misconfiguration. The third key finding I want to talk about was cyber fraud takes center stage. Phishing attacks, they are still around. They're on the rise. Why? Because they work. It used to be that attackers were looking for domain credentials, but now with all these companies moving data to the cloud, if you can get a privileged cloud account, if you can get those credentials, then you pretty much have the keys to the kingdom. And so that's really what this attack demo is going to address. So to set this up, I have a container sitting in Azure here, and first, let me point out that this is not an attack on Azure at all. These types of exploits are available on every major cloud platform. I'm not trying to single out Azure at all. In addition, I'll also be doing an Mfa Bypass. That's not to say MFA is bad technology. It's great technology. I encourage everyone to use it, but it also is not a silver bullet to your security needs as well. So to set this up, I've got my container here, and you'll notice that it is marked as private. There's no public access to this container at all. If we go inside, we'll see there's two files in here. One of them is PII data, and the other is the exact same file that has been microsharded. Now, if we look at the properties of this file, you'll also notice that I do have encryption turned on. So we can see here, server encrypted is true. So I am using the built-in cloud provider security encryption here in this container. So this is a phishing attack. So that would start with someone with privileged cloud credentials. So this would be like your cloud admin or developer or something like that. And really, at the end of the day, all I need to do is get them to click on an email. So here is my poorly formatted phishing email. And I'm going to go ahead and click on this. And it looks like maybe it's a matrix MP4, but it's actually an HTA file, which is going to exploit the browser and basically just set up a reverse shell out to the attacker's system. So when we move over to the attacker's system, we can see that I've got my reverse shell in here now. So let's take a look at that. All right, so I am on the victim's system here, and now I can run my discovery script. So what this is going to do, it's going to look for any type of cached access tokens on the system, and there's none. But wait, all the attacker has to do is stand by. If you're admins or anything like me, I don't do a lot of stuff in the browser. I'm more of command line, running scripts to help automate my job and make my tasks easier. So I think that you'll find that's pretty pervasive throughout your administrators. And so I have set up this account as with MFA. So I am just going to log in there. And hopefully I get that right. I should be getting my code here. So let's plug that in. All right. So I've went through, got my MFA authentication going, and now I'm logged into Azure through a PowerShell. Now, one of the things that this does is you can't have to authenticate every 15 minutes or every time you run a script or enter a command line. So your access token is actually cached, and it's cached in clear text in an unprivileged directory. So from the attacker's point of view, that makes it really easy to get that. So I actually don't need the administrator's credentials, username, password, or anything. All I need is his access token. It shows that he already authenticated and who he or she is. So let's go back to the attacker, and we're going to run that script again. So this script, what it's doing is it's looking for cached credentials for Azure in this case, and it found one. And what it does then is actually pushes down a PowerShell script to the victim's machine. So now everything done from there is done with the identity of the administrator and their permissions, and it's done from their machine. So even if you have controls like MFA, like VPN or IP restrictions, it's not going to matter because the attack is indistinguishable from the actual administrator doing their job. And what this script does is it actually goes to the container that I showed you earlier. It lists out those files, and then it actually downloads them to the victim's machine, and then it exfiltrates those files to the attacker's machine over the reverse shell. So what does that mean? So you'll see there's a new loots directory here on my desktop, and we can go in and look at what is in there. It's the same two files that we saw up in the container, now on the attacker's machine. So let's take a look at those files. Here's the PII file. And the first thing to notice is that it's totally in clear text. If you remember back when I was showing you the container, that file was encrypted. I was using the built-in cloud encryption on that file. Yet I didn't have to do anything. The attacker doesn't even know that that file was encrypted. That's how transparent the encryption is. So you don't have to hijack any keys. You don't have to issue any commands to the cloud to unencrypt that file. Just by the nature of having the right access token, and privileges and requesting that file, it is automatically decrypted for you. So truly transparent encryption. Now let's look at the other file. So this again is the exact same file, but it's been microsharded. Look at that. All right, you can't really make any sense of this file. Now, technically this is 1/5 of the file. When I set up the microsharding engine, it had 5 different storage locations. So this file was compressed, it was shredded, it was poisoned, and then distributed to 5 locations. So technically this file is 1/5 of this sensitive information, but it is no longer sensitive. You can tell there's no real way to make heads or tails of this. There's some text, there's some binary data. That's because of the compression. And there's really no way, and there's no indicator where those other 4 locations are. So, you know, if an attacker wanted to make use of this data, they would have to find out those 4 locations, which there's no indication here from that. They would have to take that information together. They would have to break it back into the 4 chunk shards, figure out how to put those shards together that is actually reconstitutes the data, which is mathematically incredibly hard to do. Then they would have to somehow identify the poison data and strip that out and then expand the file again. So it's virtually impossible task to try to recreate this data and make anything useful out of it. So, you know, no one can necessarily prevent a breach from happening, but you can prevent the outcome of that breach, whether the attacker gets all your data in a very usable form or whether they get your data in a virtually unusable form. The other thing I thought that was interesting about that is the microsharded file, and here I have it on the victim's machine as well. I downloaded it here before exfiltrating it to the attacker's machine. And if we open up the exact same file in Notepad, it just shows up as Asian characters, right? So Notepad is basically looking at this data, this file, and it has no file format information. You know, there's no headers or anything like that in the file. There's no file extension in the file. It's just a random string of bytes. And so it does its best and decides that, oh, this must be Unicode characters, and displays it like that. So you can kind of, you know, understand that from an attacker's point of view, it would be really hard to make sense of this data, much less try to put it together. It'd be nearly impossible.
One of the common questions we get when we run this demo is why hasn't the endpoint protection caught it? And the answer is, with a lot of admins, developers, and those with the programmatic access where they need or desire to operate via command line with the cloud platform, which opens up potential for misconfigurations and others, that their AV or endpoint policy is typically in a detect only or a more liberal policy that allows things like auto IT and shells and PowerScript to run. And so they're the ones that kind of keep an eye on, in my opinion, and a valuable target. So that at large, all of the controls that we've employed in the data center, they don't work the same way. There are features and capabilities in cloud platforms that are actually present risk. I mean, they make it easier to do your job, but create more attack vectors. So the question that I ask is, if we continue to use these same technologies and the same approach, how can we expect different results, right? AKA not as many breaches. So let's just cover how Microshard technology works. And I've got a very simple example here of an unstructured piece of data, a Word document, a PDF, an Excel spreadsheet. Could be sensitive, could be not. But we're shredding this document into 4-byte microshards. So the fundamental tenet of Microshard technology is we want to desensitize or eliminate the sensitivity of data. And the way that we're doing that initially is by shredding it into pieces that are too small to contain anything like a social security number or a credit card number or anything that could be company sensitive or IP. And so in this case, we end up with 80 pieces. So the next step is also very important, right? We're taking this next level by creating a number of new smaller files, but the microshards are kind of mixed up in these new containers, these new files that we create. And these new containers don't contain anything useful, right? From the data being so small to get too small to contain sensitive information to the original source file names or any extensions or any location data. And so each individual new Microshard container or file is not useful at all. We're also using a combination, or Microshard technology leverages a combination of compression on the front end, which serves the purposes of making files smaller, but also injects poison data. And Ed and Bob have both mentioned this, but we want to add friction to the attacker, to people that aren't supposed to see the data itself. We want to make it as difficult as possible for them to make valuable use of this data. But the combination of compression and poison data is interesting because even if you were to retrieve all of the pieces to this puzzle or source file and put them back together in the right order, you'd still have to define and extract or cull out the poison data to uncompress on the front end of that process. And so it just adds another layer of protection for your data. But lastly, based on the number of storage locations that you have or configure in whatever Microshard technology product you're using, that data gets sent to disparate, disconnected, a lot of times storage locations, right? And the idea is that we're not only supporting segmentation with Microshard technology, but segmenting the data from itself at a near atomic level. And the result in the case of a breach of any one of these storage locations is that 75% of the data that you need to put this file back together, the pieces of the puzzle, put it back together, reside elsewhere. It's also in any individual location, incomplete, right? And largely unreadable. So there's really three desired effects or impactful, valuable, measurable results to deploying Microshard technology. The first is a data security, right? Fundamentally, if you eliminate data sensitivity, you reduce its value to nothing. You reduce the attack surface. Today, our attack surface is the total of all of our data, and that's an extremely difficult proposition because now we're working remote, working in the cloud. Data is stored on desktops, laptops, servers, cloud infrastructure, object, cold storage. Where is it? How sensitive is it? And what do we do to protect it? And a lot of the data, as in the first slide here, it goes unencrypted when it's stored in the cloud. So add friction and eliminate the value of the data to your adversary. And so the question we typically get is, where do we start, right? What data should we Microshard? The answer is, what data is valuable to you? Because if it's valuable to you, it's valuable to an attacker or someone that's seeking an unprotected volume, right? So we recommend you start with, for lack of better words, crown jewels, right? Data that could hold company secrets, intellectual property, and especially customer data. And what has emerged has likely the most important data to secure is your internally developed code, right? Which in many cases will contain access credentials and encryption keys and other items that enable it to operate in your environment, but would also enable an attacker to steal yours or your customer's data. So from a privacy perspective or data privacy perspective, the question that we ask is, who should see your data? But the answer there really should be another question, and that question is, who can see your data, right? And the difference between who should and who can see your data, it should be alarming from a security perspective. And as Zach will demonstrate, there are those that should have cloud platform access to do their job and can see your data, but should they be able to see the data, right? And the answer is typically no. You don't want these admins to do that. And the other question and a concern for many non-US companies is the potential for your cloud provider, contractors, managed service providers to access your data via new measures or new laws, such as the Cloud Act. From a compliance perspective, can microsharding or Microshard technology make compliance easy? I don't think anything makes compliance easy. It's incredibly difficult, right? There's room for interpretation. Auditors will have different opinions, but it certainly can decrease the operational burden and many of the related costs, right? Especially when we look at the potential for fines or breach penalties. Our goal is to reduce that attack surface, to separate it, right? Help you achieve that zero trust on the back-end infrastructure, on the platform access, right? Separating those admins and IT and contractors from your data, and then to reduce the sensitivity class to support good compliance there.
I think we're up at Q&A time.
There is a little box down towards the bottom of the screen if you're interested in asking a question, I think, to sum things up. ShardSecure is the first to market with Microshard technology. And again, our goal is to eliminate data sensitivity to support the security that you're doing today and elevate your security posture, your privacy and compliance beyond what you can do with existing controls. So if you're looking for additional information about the tech, about us, you can hit our website at www.shardsecure.com or info@shardsecure.com. And of course, you can find us all on LinkedIn and other social media if you wanted to contact us directly.
You know, one question that I just got texted by some people who are listening, I guess they're just texting me for some of these, but is about compliance. Maybe, Bob, you might have some thoughts on there, wondering whether the compliance auditors have picked up on this technology and what you see ahead in the compliance community for sharding.
We have spoken with probably a dozen or more auditors and a few compliance officers. They were very interested. Most of them have told us that this technology is reducing their attack surface. And many of them also said that they believe it does reduce, if not eliminate, the sensitivity of the data. So that's what we have heard so far. I think it also depends on the industry. As you know, financial services, it might take longer for them to buy into this, but other industries like healthcare and some others, from our experiences, will move faster in recognizing the value, how this type of Microshard technology can reduce the compliance burden.
It would seem to me, I know most of the compliance audits that I've read over the years included findings, obviously, and who knows, maybe there may be some ongoing investigations right now that have findings where there is back-end access that would have benefited from sharding. But usually, to reduce risk, auditors will include sections where they're recommending risk reduction, mitigation tools. So that might be, if there's some folks who are listening from that community, this might be something to look at, to include in cloud audits when you are looking at sensitive data and so on. A question I have for you guys is around the existing big three. What's been your interactions with the big cloud providers? How has that interaction gone?
Yeah, I think we're spending good amount of time, obviously, with at least the big two, AWS, Azure. I mean, we support the big four cloud providers right now, but from certainly having quite a lot of conversation with the big two regarding potentially how do we help them, how do we work with them, right, in convincing some of their customers to go even faster, even moving more sensitive data to the cloud. So I think we have a very friendly relationship with them, and especially the big two. We have some pretty good level relationships with both of them. And we need them to continue improving their security of the cloud, right? But data security, not just this company, but the data security companies need to continue to do a better job in helping customers secure the data in the cloud. I think that's pretty clear. A lot of times not just security. We were just talking to some customers and prospects that they were talking about, hey, they were not sure if some of the very sensitive data in the cloud is encrypted, and that they couldn't give us an answer. It was pretty interesting. So that's a lot of time we talk about it like is cloud misconfiguration. At the end of the day, is human error. And you and I've seen it, especially many times in the old days, enterprise security on premises, most of them are human error. And I think you're going to see this repeating the same in the cloud space. And of course, the cloud providers has again done a good job securing what is in there, right? What of the cloud. And I think by and large, they are, it's more secure, especially for smaller companies to go to the cloud providers and put the workloads and the resources there. But if you are major banks or major technology companies, then there's still a lot of things that you can do, right? In addition to lay on top of what the cloud providers are doing today.
Yeah. One of the attendees is asking a very good question. It's one of the first questions I'd ask you guys when I started looking at the tech, and it's around, when you're sharding and you're retrieving files, He's asking about retrieval time, but just in general, what's the experience retrieving files that have been sharded? Would you notice any difference at all?
So there is a little bit of latency measured in milliseconds right at the very beginning of a read or write where we're actually reassembling the pointers, but we actually make it up in throughput. So because we're using A, compression, if it's a compressible file, and B, we're using parallel I/O on the back end. So instead of retrieving something from a single storage location, we have 5 or 10 or 15 threads opening up, pulling smaller sections of those files and piecing them together. So in throughput, we generally actually outperform standard storage technologies. So we can actually speed things up.
That's an unusual result, right? Normally you would think that there would be, but I guess it just points to the
first
fact
security product.
Well, there are places where you can optimize, and it looks like you guys have done that.
Yeah, I mean, we were just doing testing with a major storage provider, like we improved the performance by at least 30%.
Wow.
And also it's really the parallel read and write, parallel I/O, right? And especially as the world moving to more multi-cloud environment, this actually has additional benefits, right, for us, because in a multi-cloud environment, that does actually make a lot of sense to consider this type of micro-sharding or sharding technology.
So at some point you'll change your name to Shard Perform, right? People buy speed up your cloud access. That's so funny.
I mean, it's interesting because, again, it's not just the company, but like from a sharding perspective, as you know, sharding has been around for decades for performance and resilience. And the innovation about micro-sharding is so small, right? The data set is so small, down to single-digit bytes, that has immediate security benefits to it. So this is actually, when you look at it longer term, this platform, this type of Microshard platform, right, certainly has security benefits, but also have performance and resilience benefits as well.
You guys tend to see bigger companies coming and asking about this technology, or have small and medium-sized businesses shown some interest here at all?
I think mostly bigger companies. If you are smaller, you could be mid-sized, but if you have a lot of sensitive data, if you're managing $50 billion assets, asset management firm that are in the cloud or really wants to move to the cloud, they are aware that what is provided by the cloud provider just not enough, right? I mean, from a data security perspective. So they are definitely interested in that. But other than that, I think it will be Fortune 1000 type of companies.
I mean, regardless of the size of your company, we still all face the same challenge, right? We all want the benefits of the cloud, right? But then we typically go in and we build it, right? And build all these applications and the storage volumes. And then we're like, hey, let's add security, right? And then we go and we try to add security to it. And then, hey, let's make that whole thing compliant, right? And it's very difficult for companies of any size. I mean, I think Microshard technology presents kind of an interesting, kind of low touch, automated, persistent opportunity to reduce the operational workload on your teams and also ensure before data is written to any of these cloud storage locations that it's already been handled, right? The job of desensitizing and eliminating any value to anyone at rest has been handled, right?
That's great. Hey, I have one last question here in my queue here, and it's around POCs. So I don't know whether Zach, Robert, or Bob who would take this one, but if somebody wants to do a POC, I assume they'll visit you guys on the website, but take us through what the experience is if someone wants to, get some sense of how the technology would work. How do you guys work those?
Yeah, so I mean, we're happy to do proof of concepts with anybody. It's a really pretty painless process. Our deployment tools have really automated building everything, including the nodes, the clusters, the load balancers, even SSL certs and stuff as part of the POC, so that you can get up and running in about 15 minutes. So it's super, super easy. And then from there, you can test it a multitude of ways. And again, it's a low touch virtual appliance. So there's really not a whole lot of management you have to do. you can kind of just treat it like a NAS front end and point different applications or code at it to store that data and validate, the security, the privacy, compliance and performance of it in your environment. And you could probably get that done in under 4 weeks with probably just a few hours working on it a week. So it's very a low effort way to evaluate the technology.
That's great. Now we've got a question that just popped up here in the Q&A asking about multi-cloud. So when somebody does go into multi-cloud, does this make it easier, more difficult? What's been your experience for companies that want to take advantage of the economics and security and other types of benefits that come with multi-cloud? What's been your experience with those customers?
Yeah, so I mean, we are totally agnostic. You can run us in your data center. You can run us in any of the major cloud providers. The storage locations can be mixed and matched as well. So you could run us, you could run the ShardSecure engine in AWS, for example, and have storage locations in Azure and IBM and AWS and even on-prem, just mix and match with different policies that send data different places. The other thing we have the ability to do is actually to move that data without having to reconstruct it. So if you decide that maybe you're split between AWS and Azure, and you decide that, I don't know, maybe Google is going to give you much better storage costs, you can just spin up a Google account and just click on your AWS buckets and say migrate to Google, and it'll migrate them over to those new buckets, and they stay in Microshard form. So it really kind of, A, they transfer pretty quickly, and B, it really lowers the chance of, man-in-the-middle attacks, or what happens a lot of times people migrate is there's a lapse of security, right? They post some data somewhere to transfer it, and it's unencrypted, and sometimes it has public access because they're just trying to get their job done. I just saw a breach the other day that was like a few weeks ago that was kind of the case where someone was migrating data. So we allow you to migrate data across clouds and then back again, or from on-prem to the cloud and back again, really easy, like literally a few clicks of a button, and it's all handled for you.
And Zach, is there fault tolerance in there? That's another follow-on question here that's popped up. So
So we have the ability to use secondary buckets, sort of like hot spares. So what that means is, if you have, I don't know, US East 1 goes down, you can have a designated hot spare bucket in US East 2 or US West 1 or something, and the ShardSecure engine can automatically go fail over to that backup bucket of data to keep your services intact.
That's wonderful. Really, really good, very feature-rich platform. Bob, I want to congratulate you guys on really, highlighting a good technique for the community, as we've discussed, and a really nice platform. And I'll tell you, I have seen the demo a couple times, Zach. I know it works great. So I hope people sign up and come sit through your demo. I think it's quite impressive. It shows a very clever methodology and approach, step by step, and hopefully people will want to spend some time with you. That's great. Well, Bob, I appreciate you including me in the discussion. I know for my team, we've enjoyed the interaction. I hope people have enjoyed the session. I'll turn it back to you.
Yeah, thank you, Ed, for joining us, our guests here. I think this is really, from an industry perspective, as we all know what is going on, the data is at risk when you think about it, like especially in the cloud, and we think you should consider different type of technologies to secure those data. So I want to thank everyone for joining us today, whether live or on demand.
Think about all the sensitive data your business is storing. In the event of a data breach by external attack or internal human error, this data can be exposed. What damage could it do to your business? ShardSecure provides an innovative data security solution. Microshard technology that mitigates data breach risk, ensures data privacy, and improves cloud performance. ShardSecure takes data and breaks it down to the byte level to eliminate its value. Data flows from your front-end applications and services to the ShardSecure engine, where we compress, then shred it into tiny microshards. We add poison data before mixing the microshards into multiple containers that do not have file names, extensions, or location information. The new Microshard containers are streamed to your cloud and on-premises storage locations. Your data can be reassembled and recalled to you at any time. But should any of these cloud locations suffer a security breach, only incomplete and unreadable data is exposed. ShardSecure's Microshard technology is an innovative data security solution that eliminates data sensitivity to ensure total privacy for data at rest and in motion, keeping your business protected. Find out more at ShardSecure.com.